Simultaneous equations. It is a part of O-level and IGCSE additional mathematics syllabus. We'll be doing simultaneous equations when there is one equation linear and another one is non-linear. Before we dive in, you need to be comfortable with 3 skills. 1. Substitution method for solving equations. Solving quadratic equations using factorization. Handling equations with algebraic fractions. Let's do some examples related to these. First example is, use the substitution method to solve x plus 2y is equal to 11 and 4y minus x is equal to minus 2. This we can say is equation 1. This equation 2. We can see in both the equations, x is a variable which has coefficient 1. It has coefficient 1 and it has coefficient minus 1. We have to try to make that variable as a subject whose coefficient is 1, either 1 or minus 1. In this case, in both the equations, the variable x has coefficient either 1 or minus 1. So we can make x the subject either from equation 1 or from equation 2. Let's make x the subject from equation 2. When we will make x the subject from equation 2, we will take x on this side and we will take this minus 2 on this side. We have to make sure that the subject of the equation is positive. When we will take x on this side, it will become positive x. And minus 2 on this side, it will become plus 2. So the equation is 4y plus 2. We can label this equation as equation 3. Now, we will substitute this equation to equation 1 because we have already made the subject from equation 2. So don't do this mistake. If you have made the subject from equation 2, then you have to substitute it in equation 1. Substitute x in equation 1. When we will substitute it in equation 1, in place of this x, we will have 4y plus 2. Then we have plus 2y here, plus 2y is equal to 11. Let's solve this. 4y plus 2y is 6y. 11 minus 2 is 9. So we have here y is equal to 9 upon 6, which is further simplified to 3 upon 2. Now we will substitute this in third equation so that we can get the value of x. So x is equal to 4 into 3 upon 2 plus 2. We'll cancel out this. 2 ones are 2, 2 twos are 4. And then it will be 6 plus 2, which is equal to 8. So the coordinates are 8, 3 upon 2. The value of x is 8 and the value of y is 3 upon 2. So this is the knowledge you must have before moving on to simultaneous equations in which there is one equation linear and another one is non-linear. Another concept which you must know is solving quadratic equations using the factorization method. First example, we have x squared plus x minus 6 is equal to 0, as it is a quadratic equation and we have to use factorization method to solve it. To factorize it, we have to use middle term breaking method, in which we have to break up the middle term. For that, we multiply x squared term by the constant term. Make sure that the equation is arranged in order. It is to be in order of ax squared plus bx plus c. First of all, we will multiply x squared by minus 6. We'll get minus 6x squared. Now we'll make the factors of this minus 6x squared in such a way that when we will add or subtract, we get plus x. So the factors of 6 are 3 and 2. So we can take 3x and 2x. And when we will subtract 2x from 3x, we will be getting plus x. It means that we have to take 2x as negative. X squared plus 3x minus 2x minus 6 is equal to 0. In place of this x, you have to write 3x minus 2x because 3x minus 2x will give the result as x. Then we have to take common. X is common. In bracket x plus 3, minus 2 is common. X plus 3. We have x minus 2 and x plus 3. Now we will equate each factor to 0. X minus 2 is equal to 0. X plus 3 is equal to 0. X is equal to 2 and x is equal to minus 3. Let's solve another example of solving quadratic equation using factorization. In this example, we have x squared minus 10x plus 16 is equal to 0. First of all, we will multiply x squared by 16. So we will get here 16x squared. We will make factors of 16 in such a way that we get 10 as a result. So the factors of 16 are 8 and 2. 8x multiplied by 2x will give us 16. And when we will add 8x and 2x, it will give the result as 10x. But we have here minus x. How can we get this as minus when we have both the factors as negative? So we will take here x squared minus 8x minus 2x plus 16 is equal to 0. X is common. X minus 8 minus 2 is common. X minus 8 is equal to 0. X minus 2, x minus 8 is equal to 0. Then we will equate each factor to 0. When x is equal to 2 and x is equal to 8. Another example, 6x squared plus 11x minus 10 is equal to 0. First of all, we will multiply 6x squared by 10. So we will get here minus 60x squared. Now we have to make factors of minus 60x squared in such a way that we get plus 11x. We have 4 multiplied by 15 is 60 and 15 minus 4 is 11. So one of the factor is 4x, another factor is 15x. When we will subtract, we will get the answer as 11x. So for that, we must have one of the term as negative, either 15x or 4x. So we see that here it is plus, so it means that the greater number will have plus sign and the smaller number will have minus sign, so that we can get the answer as positive 11x. 6x square plus 15x minus 4x minus 10 is equal to 0. We cannot take 6 as common, so we will see which is common in these two numbers. The common factor is 3, so we will take 3x as common. 2x plus 5 minus 2, 2x plus 5 is equal to 0. Whenever we take minus sign as common, then this sign is to be changed. So 3x minus 2, 2x plus 5 is equal to 0. We'll equate each factor to 0. 3x minus 2 is equal to 0. 2x plus 5 is equal to 0. So x is equal to 2 upon 3 and x is equal to minus 5 upon 2. Now we will do example related to solving equations involving fractions. You can see here 7 minus 2y upon 2 whole square minus 4y square is equal to 8. So first of all, we will write square on numerator as well as on denominator. We cannot directly take the square of 7 and the square of 2y. We have to apply here the identity a minus b whole square is equal to a square minus 2ab plus b square. Here, in place of a, we have 7. In place of b, we have 2y. So we will substitute in place of a, 7, and in place of b, 2y. When we will simplify it, we will get 49 minus 28y plus 4y square. So we will write here 49 minus 28y plus 4y square upon 4 minus 4y square is equal to 8. Now we can see here it is a fraction and here it is a whole number. We will consider that it has denominator 1. So we have to take 4 as LCM. It means that we have to make this denominator 4. So we will multiply this by 4 as well as we will multiply numerator by 4. So we will get here 49 minus 28y plus 4y square minus 16y square is equal to 8. When we'll simplify it, we will get minus 12y square minus 28y plus 49 is equal to, we can do the cross multiplication. So we will get here 32. So finally, we have here minus 12y square minus 28y plus 70 is equal to 0. 49 minus 32 is equal to 70. Now we can make this term of y square positive. We can multiply this whole equation by minus 1. So this will become 12y square. This will become 28y. And this will become minus 17. Now this can be solved using factorization or using quadratic formula. According to quadratic formula, we have x is equal to minus b plus minus b square minus 4ac upon 2a. And this is to be used when we have quadratic equation in the form ax square plus bx plus c is equal to 0. In this case, we have equation in terms of y. When we'll have equation in terms of y, then we will write here y. So first of all, we will write the values of a, b, and c. A is equal to 12, b is equal to 28, and c is equal to minus 17. Now, y is equal to minus 28 plus minus under root 28 square minus 4 into 12 into c, which is minus 17, upon 2 into 12. So we have here minus 28 plus minus under root 1600 divided by 24, which is equal to minus 28 plus minus 40 upon 24. We can write here minus 28 plus 40 upon 24, or minus 28 minus 40 upon 24. So we have here 12 upon 24, or minus 68 upon 24. This will be 1 upon 2 minus 17 upon 6. Finally, we have 1 upon 2, or minus 2 whole 5 upon 6. Let's solve pairs of simultaneous linear and nonlinear equations. In the first question, we have y is equal to x squared and y is equal to x plus 6. First of all, we can name this as equation 1 and this as equation 2. Then we have to see which equation is linear and which one is nonlinear. First one is nonlinear and the second one is linear. How you will come to know whether the equation is linear or nonlinear? If an equation has square on the variable, then square or cube, then it is nonlinear equation. Linear equation always have 3 terms. One of the term having y, another term x, and the third term constant. So if we see here, in this equation, we have y is equal to x squared. X has square on it So it means that it is nonlinear equation. Here we have three terms. One is y, another term having x in it, third term constant. In these two equations, y is the subject. We can easily solve these two equations by simply equating. As we have here y is equal to x squared and y is equal to x plus 6, we can simply write x squared is equal to x plus 6. X squared minus x minus 6 is equal to 0. Now we'll solve this equation by factorization. We'll use middle term breaking. We'll multiply x squared by minus 6. So we will get minus 6x squared. And the factors of minus 6 are 3 and 2. When we will subtract these two, we will get x. As x is negative, so we have to write negative sign with greater number. So the factors are minus 3x and 2x. In place of minus x, we will be writing minus 3x plus 2x minus 6 is equal to 0. Then we will take common x minus 3 plus 2, x minus 3 is equal to 0. X plus 2, x minus 3 is equal to 0. Then x plus 2 is equal to 0. And x minus 3 is equal to 0. So we have x is equal to minus 2 and x is equal to 3. Now we will substitute these values in equation 2. We have to always substitute the values of x in the linear equation. So we have here y is equal to minus 2 plus 6. Y is equal to 4. For this value of x, we have y is equal to 3 plus 6. So y is equal to 9. The coordinates are minus 2, comma 4, and 3, comma 9. These were the simple equations which we have solved. Let's solve another pair of simultaneous equations. We have one of the equation is x squared minus xy is equal to 0. Another equation is x plus y is equal to 1. And we have to solve these two equations simultaneously. First of all, this equation you can say is equation 1. This equation is equation 2. Then we will decide which equation is linear and which one is non-linear. You can see here it is x squared, so it is non-linear. This one is linear as we have one of the term in x, another term in y, and third term is a constant term. You have to always make subject from linear equation. We have here x whose coefficient is 1. We have y whose coefficient is 1. So we can make either x the subject or y the subject. Then we will see other equation in which we have to substitute either the value of x or the value of y. Now, if we make x the subject, then we have here square on it. So it's better if you make y the subject, then you will have to do less number of steps and it can easily be solved. So you have to make here y the subject. So when we will make y the subject from equation 2, Then we have here y is equal to 1 minus x. Once we have formed the equation, we can say that this equation is equation number 3. We will substitute this y in equation 1. We have made the subject from equation 2, so we have to substitute it in equation 1. We have here x squared. This will remain as it is, minus x. In place of y, we will substitute 1 minus x. We will simplify x squared minus x plus x squared is equal to 0. 2x squared minus x is equal to 0. We will take x as common. 2x minus 1 is equal to 0. Whenever we have equation without constant, then we can simply solve it by taking common. X is equal to 0 and 2x minus 1 is equal to 0. X is equal to 1 upon 2. Now we'll take out the values of y. For values of y, we will substitute the values of x in equation 3. You can substitute in equation 2 as well. But do not substitute in non-linear equation. You have to always take out the value of y by substituting in linear equation, either in equation 2 or in equation 3. So we have y is equal to 1 minus 0, which is equal to 1. Here we have y is equal to 1 minus 1 upon 2. So y is equal to 1 upon 2. We have coordinates 0, 1 and 1 upon 2, 1 upon 2. Let's solve another pair of simultaneous equations. We have y is equal to x minus 1. Another equation is x squared plus y squared is equal to 25. First of all, we will write that this is equation 1, this equation 2. Then we will decide which one is linear and which one is non-linear. We have here x squared, y squared, so this is non-linear. And this one is linear as it has one term in y, another term in x, and third term is constant term. In this equation, y is already the subject of the equation. So we don't need to rearrange. We just have to substitute the value of y in equation 2. Substitute y in equation 2. So when we will substitute y in equation 2, there is square on it. So we will write x minus 1 in bracket and put square on it. Now, as we have x minus 1 whole square, so we will apply here identity to solve. X minus 1 whole square is equal to square of x minus 2 into x into 1 plus 1 square. So we have here x squared minus 2x plus 1. So we can write here plus x squared minus 2x plus 1 is equal to 25. Then we have 2x squared minus 2x plus 1 minus 25 will be minus 24. We can take 2 as common so that we can get a simple equation is equal to 0. Then we have x squared minus x minus 12 is equal to 0. Now we'll solve this quadratic equation by middle term breaking. We'll multiply minus 12 by x squared, so we will get minus 12x squared. And the factors of 12 are 4 and 3, which will give the result as 1. As we have here minus x, so we will take greater number as negative and smaller number as positive so that we can get the result as minus x. X squared minus 4x plus 3x minus 12 is equal to 0. X is common. X minus 4 plus 3, x minus 4 is equal to 0. X plus 3, x minus 4 is equal to 0. X plus 3 is equal to 0. And x minus 4 is equal to 0. So x is equal to minus 3 and x is equal to 4. Now we'll take out the values of y, for which we will substitute the values of x in equation 1. Y is equal to minus 3 minus 1. So we have y is equal to negative 4. Y is equal to 4 minus 1. So we have y is equal to 3. So the coordinates are minus 3 comma minus 4 and 4 comma 3. Let's solve another pair of simultaneous equations. We can consider this as equation 1. This is equation 2. This equation is linear equation. And this one is non-linear, as we have x plus 1 whole square. Now, we have to make one of the variable as subject from linear equation. Either we have to make y the subject or we have to make x the subject. In the linear equation, x has coefficient 1 and y as well has the coefficient 1. So either we can make y the subject of the formula or x the subject of the formula. So from equation 1, we'll make y the subject of the formula. Y is equal to 5 minus x. Now we will substitute this in equation 2. In equation 2, we have x plus 1 whole square plus y plus 1 whole square is equal to 25. We can first solve these brackets and then substitute, or we can substitute it directly here in place of y, 5 minus x. X plus 1 whole square plus 5 minus x plus 1 whole square is equal to 25. We have here x plus 1 whole square plus 6 minus x whole square is equal to 25. Now we can expand these two brackets using identity. Whenever we use identity, we have to take the square of both the terms. Square of x, x square, square of 1 will be 1. And then we'll multiply these two together. X multiplied by 1 is x, and then multiplied by 2, so we will get plus 2x. In the same way, we will expand this bracket. Square of 6 is 36. Square of x is x squared. Multiply 6 by 2 and then by x. And as we have minus sign here, so it will be minus 12x is equal to 25. We'll simplify it further. 2x squared minus 10x. 36 plus 1 is 37. And 37 minus 25 is 12. Now we can take 2 as common so that we can get a simple equation. X squared minus 5x plus 6 is equal to 0. Now we have x squared minus 5x plus 6 is equal to 0. We can solve this equation by factorization using middle term breaking. So first of all, we'll multiply 6 by x squared. So we'll get 6x squared. We'll make the factors of 6 in such a way that we get minus 5. So minus 3 and minus 2, when we'll multiply together, will give 6. And when we will add together, it will give minus 5. So we have minus 3x, minus 2x, which will give the result as minus 5x. We can write here x squared minus 3x minus 2x plus 6 is equal to 0. We'll take x as common. X minus 3 minus 2 in bracket x minus 3. X minus 2, x minus 3 is equal to 0. X minus 2 is equal to 0. And x minus 3 is equal to 0. So x is equal to 2 and x is equal to 3. Now we'll substitute these values of x in equation 3. So y is equal to 5 minus 2, y is equal to 3, y is equal to 5 minus 3, which is equal to 2. So we have coordinates 2, 3 and 3, 2. When in x is 2, y is 3. When x is 3, y is 2. Let's solve another pair of simultaneous equations. In these equations, one of the equation is having fraction. First of all, we will write which one is linear and which one is non-linear equation. This is equation 1 and this one is linear. As we have one of the term in y, another term in x, and a constant term. This is equation 2 and this is non-linear. Now the question is, we have one of the term in y, another term in x, and a constant term. Then why we are saying that this is non-linear? Y and x are there in the denominator. So whenever y or x are there in the denominator, then we say it is non-linear equation. In linear equation, y and x must be in numerator. First of all, we will simplify this non-linear equation by making the denominators same. We'll multiply this denominator by x. So we will multiply numerator also by x. We will multiply this denominator by 3y. So we will multiply this as well by 3y. So we have here common denominator 3xy. Here we have 2x minus 3y is equal to 2. Then we will do cross multiplication. 2x minus 3y is equal to 6xy. This is equation 3. Now we have to make either x or y the subject of the equation from linear equation. To avoid getting fraction, we have to make x the subject of the formula. So from equation 1, we will take minus x here and 3 on this side. So when we will take x on that side, it will be positive. And when we will take 3 on this side, it will be 3y minus 3. We have to always make the subject of the formula positive. This is equation 4. Now we will solve these two equations simultaneously. We will substitute x from equation 4 to equation 3. 2 into 3y minus 3 minus 3y is equal to 6y into 3y minus 3. In place of x, we have substituted 3y minus 3. 6y minus 6 minus 3y is equal to 18y squared minus 18y. We will solve this. 6y minus 3y is 3y, and when we take it on other side, this will become minus 3y. 18y squared minus 18y minus 3y will become minus 21y. Minus 6, when will be taken on other side, will become plus 6. We'll take 3 as common. We have 6y squared minus 7y plus 2 is equal to 0. We have quadratic equation, so we'll solve it by middle term breaking. We'll multiply 6y squared by 2, so we'll get 12y squared. We'll make the factors of 12 in such a way that we get minus 7. So minus 3 and minus 4 will give the result as minus 7. And when we will multiply these two, we will get plus 12. So we have factors minus 3y, minus 4y, which gives the result as minus 7. We will write here 6y squared minus 3y minus 4y plus 2 is equal to 0. 3y is common. 2y minus 1 minus 2 is common. 2y minus 1 is equal to 0. 3y minus 2 and 2y minus 1 are the factors. We'll equate 3y minus 2 to 0 and 2y minus 1 to 0. We have y is equal to 2 upon 3 and y is equal to 1 upon 2. To find out the values of x, we will substitute these values of y in equation 4. X is equal to 3 into 2 upon 3 minus 3. So x is equal to 3 and 3 would be cancelled out. 2 minus 3 is minus 1. X is equal to 3 into 1 upon 2 minus 3. x is equal to 3 upon 2 minus 3 which is equal to minus 3 upon 2. Okay, we can write down the coordinates as when x is minus 1, y is 2 upon 3. When x is minus 3 upon 2, y is 1 upon 2. Let's solve another pair of simultaneous equations. We have here 3x plus 2y is equal to 10. Equation 1, which is linear. As we have one of the term in x, another term in y, and third term is constant term. Here we have x and y in the denominator. So this equation is not linear. We can first simplify this equation by making the denominator same. We'll multiply this by y. So we'll multiply numerator as well by y. We'll multiply the denominator by x here. So we will multiply the numerator as well by x. So we have common denominator xy, and we have here 3y plus 2x is equal to 5. 3y plus 2x is equal to 5xy. Equation 3. Now we have to make either x or y the subject from equation 1. As we can see, x has coefficient 3 and y has coefficient 2. So we can make any of the variable as subject. You can either make y as the subject or x the subject of the function. We cannot avoid fraction in this case. Otherwise, when one of the variable has coefficient 1, then we make that variable as the subject. In this case, we cannot avoid that. So either you make y the subject or x the subject. In both the cases, you will be getting fraction. Otherwise, we try to avoid getting fraction. So we are making y the subject from this. 2y is equal to 10 minus 3x. So y is equal to 10 minus 3x upon 2. We'll substitute this in equation 3. 3 into 10 minus 3x upon 2 plus 2x is equal to 5x into 10 minus 3x upon 2. We'll simplify it. 30 minus 9x upon 2 plus 2x is equal to 50x minus 15x squared upon 2. As this has denominator 1, so we have to make the denominator same, for which we'll multiply this by 2 and this also by 2. This will become 30 minus 9x plus 4x is equal to 50x minus 15x squared upon 2. We can cancel out this 2 and this 2. We'll have 30 minus 5x is equal to 50x minus 15x squared. When we'll take minus 15x squared on this side, This will become 15x squared minus 55x plus 30 is equal to 0. We'll take 5 as common. 5 3 is 15. So 3x squared minus 11x plus 6 is equal to 0. So we have quadratic equation as 3x squared minus 11x plus 6 is equal to 0. Now we'll factorize it using middle term breaking. We'll multiply 6 by 3x squared. We will get 18x squared. 9 and 2 are the factors of 18. 9 2s are 18. 9 plus 2 is equal to 11. As we have negative 11 here, so both the signs to be negative. Minus sin x minus 2x will give minus 11. So we have here 3x squared minus 9x minus 2x plus 6 is equal to 0. 3x is common, x minus 3. Minus 2 is common, x minus 3 is equal to 0. 3x minus 2, x minus 3 is equal to 0. So we have 3x minus 2 is equal to 0 and x minus 3 is equal to 0. X is equal to 0.3 and x is equal to 3. Now we'll take out values of y by substituting the values of x in equation 4. So y is equal to 10 minus 3 into 2 upon 3 divided by 2. This 3 and this 3 will be cancelled out. 10 minus 2 is 8 and 8 divided by 2 is 4. We'll substitute this value of x, 10 minus 3 into 3 upon 2, which is equal to 10 minus 9 is 1, so it is 1. So the coordinates are 2 upon 3, comma 4, and 3, comma 1 upon 2. If you find this helpful, give it a thumbs up and subscribe for more math tricks and exam preparation with Samathics.